Hello everyone. I've had a non-trivial number of questions regarding kind of these questions from lecture today. So what I'll do is I'll focus on this question and I'll give an alternative way of thinking about the question that might make things a little bit easier. So we'll just copy this over and pull it over here real quick. So if I want to answer this question, there's a few ways that you can think about the problem in kind of a useful way. One way is, since we already know how to solve equations or solve problems of, say, this type of form, or the one from lecture 25 where I have an equality and everything comes from z0 plus, one way to approach this problem is try to rephrase it as a problem we already know how to solve, and then just use those basic principles to solve the previous question. The other one is to use more general methods of trying to solve it, the idea of I have the stars and the bars and reordering things. So we'll kind of sit here and watch this, or examine this in two different cases. So I have 17 d100s, so I have x1 plus x2 plus etc., all the way up to x17. And I know the sum of these wants to be equal to, or I want it to be equal to 117. Now, these die, for each one of these xi's, I know this has to come from a set 1, 2, 3, all the way up to 100, right? It can't go over 100, and it can't go less than 1. Okay, so if I wanted to try to think of this question as like the bin version, what I could instead do is say, okay, I have x1, x2, all the way up to this x17, and I can represent these as little bins like this, where I draw this in, and I have my little dividers, okay? Dot, 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 bunch of dividers there. Since I have 17 variables, there's going to be 16 of these dividers, okay? So now under this framework, what I want to do is I want to place 117 balls, or stars if you will, into these dividers, right? But I have a restriction. I can't put more than 100 dots or balls or whatever you want to call them into one of these bins, and I have to put at least one in every single bin. Okay, so I have to put basically values between 1 and 100, right? This condition still applies. Okay, so if you want to think about how I would try to solve the question over in this framework, kind of the first natural thing to do is to say, well, I know how to make the stars and bars method work if there's at least one thing in every container, right? I'm sorry, if I'm allowed to put nothing in every container, and now I have to put at least one thing in each container, so why don't I just put one dot in each container to start with? So basically, what we would get from here is you go, okay, I have to do this, so why don't I just do it right now? So here's my x1, I put a ball in here, here's my x2, I put a ball in here, I put a ball in each one of these all the way up to here. Then the question is, how many balls are left? Well, there's 100, right? So now the question becomes, instead of distributing them such that I put at least one ball in each one and I don't put more than 100, it's now saying each one of these xi's, I already have the one ball in there, so it's allowed to be as small as 0, but it can't be bigger than, well, in total I can't have 100, 99, right? So that's one way of thinking about it here, and then we can talk about how to, or we will talk about how to solve that problem momentarily. Over here, the equivalent way of doing it is to say, well, I know how to solve it if this set, instead of being 1 to 100, if it started at 0, like 0 to something, right? So what I can do is ask, like, how do I go from 1 to 0? Well, what I can do is I can say yi is xi minus 1. If I subtract 1 from 1, I get 0, 1 from 2, I get 1, all the way up to my new upper bound is 99, all right? And now I want to solve the equation. Well, solve this for x, right? Plug it in. So I have xi is equal to yi plus 1. If I plug this in for each one of these substitutions, I'm going to get 17 ones, which I then subtract. So just kind of squishing this out. From there, I would get the new equation, y1 plus all the way up to y17 needs to now be equal to 100. Now, if you look, these two problems are the exact same problem, right? Finding the number of solutions to here is equivalent to finding the number of ways I can distribute 100 balls following this restriction here. So now what I've really done between all of these cases is I've just taken the question and rephrased it in different ways. Okay, so now we have the extra little restriction. The method that we kind of know to just kind of plug and chug here doesn't actually deal with this upper bound, right? It just says distributing them. There's no limit to the number of things you can have of any particular category, right? So if we choose to use that method, we need to verify that we're not including things that are not allowed under our new restriction, right? So to be explicit, I know the solution to this with no restriction, right? This is going to be, well, it's going to be a multi-choose question if you want to think of it kind of using broad principles. How many bins do I have? I have 17, so 17 would go here, and I have 100 balls to distribute, okay? This is the answer to basically the question, how many solutions of this do I have with no restriction on the yi's, right? And I'll put a yi here real quick. Okay, so that's what that answers the question to. But now we have to ask the question, does this adding this extra restriction limit any of my solutions? And the answer for this case is yes, right? I could pick the solution y1 is equal to 100, and the rest of the y's, so yi is equal to 0, here I is going to be bigger than or equal to 2 up to 17, right? 100 plus 0 plus 0 plus 0 is 100. This solution violates this condition, right? So I need to answer the question, how many solutions violate the condition? Or how many solutions with no restriction violate the thing when I add restrictions? And in this case, this is the only way that I can break it, right? Like, one thing needs to be at least 99, so it has to be 100 or bigger, and if it's bigger than 100, it would not satisfy the equation, right? So here I have to ask, how many ways could I pick one of these variables to be 100? And that's 17 because there's 17 y's, right? So this is how I get the solution over here. Now in this world where I think about it from picking, like placing the balls, this is now a stars and bars method where I've forced the balls to be in the middle, so I can rephrase this question once more to say, how many ways can I take these lines, right, my 17 lines, I'll put some dots in there so we can justify it being 17, and how many ways can I take 100 dots, right, so pretend there's 100 of these. How many ways can I put these in a string and rearrange them with an extra restriction that I can't have all of the balls in one of, like, all together. There has to be a line between the balls, right? Well, explicitly, I can't have all 100 lines together without a separating line. Okay, so the answer to this is, again, the same idea over here. If I had no restriction, if I could put all 100 balls together, then my answer would be, well, I have 16 separators, I have 17 categories, multi-choose 100, right? That'll tell me how many ways that I can put them together. But then I could treat these 100 balls as a single object that I'll just call star, right? So here it's asking the question, or I need to answer the question, how many ways can I place star, or how many ways can I rearrange 16 lines with a star? And the answer to that is there's 17, right? The star could go first, middle, here, here, here. There's 17 gaps where it can fit in. So I get a minus 17. Okay, so that's the basic idea of kind of why I was doing these manipulations over here, why I get overcounting, right? This 99 is the fundamental problem. And it's an alternative way of thinking about it in terms of distributing balls amongst little bins. Okay, one kind of thing that I'll end as a final comment. If this number here was much bigger, say if this is 101, now the problem becomes even worse, because I could have one of the y's be 100 and something else be a 1, or I could have one thing be a 101 and the rest be 0. So there's more solutions there. And it turns out there's a nice way to handle that just by kind of, well, you'll see. That's something that we'll cover in maybe not next lecture, but definitely the lecture after that.